Today's lesson is the start of Chapter 2, and we're going to talk about quadratic functions today. A quadratic function is written f of x is equal to ax squared plus bx plus c. A, b, and c can be any numbers, and a just can't be equal to 0, otherwise you wouldn't have a quadratic function. There are a couple of forms that you might not be familiar with of a quadratic function. This is the most basic form that you have seen in the past, but there's something called Vertex form, and the book calls it standard form. But I usually don't call this standard form. I call it vertex form because you could easily find the vertex of the parabola when it's written this way. It goes like this. F of x is equal to a times x minus h squared plus k. And you might already be familiar with h and k when you did equations of circles, because h and k were the coordinates of the center of the circle when you did the center radius form of a circle. Well, h and k, those are the coordinates of the vertex of the parabola. For example, if I have f of x is equal to 3 times x plus 1 squared minus 3, you'd be able to graph this pretty quickly from the last chapter, but you could immediately identify the vertex of this parabola as -1, -3. Because you know this has been shifted to the left by 1 and down 3. A quadratic function, the graph of a quadratic function also has an axis of symmetry, which is a vertical line, and it is x is equal to h. So in this example, the axis of symmetry is x is equal to -1, and the line x equals -1 would go right through the vertex of the parabola. One of the big jobs that we're going to have to do with this part of the chapter is change a quadratic function that's written like this, ax squared plus bx plus c, change it into vertex form so we could easily graph it. If you're given a quadratic function in this form, it's not quite as easy to graph as it is if you are given it written in this form, because you're familiar with the transformations that need to be done to a basic parabola. So what we're going to do is we're going to take a look at a quadratic form, a quadratic function right now in the original form, and we're going to translate that into vertex form. So we're going to translate from ax squared plus bx plus c into a times x minus h squared plus k form. And to do that, we have to complete the square. As follows. Let's say we're given f of x is equal to x squared minus 8x plus 16. And we're asked to write that in vertex form or standard form. What you're going to do is, oops, that's a bad example, sorry. Let's say f of x is equal to x squared minus 8x plus 12. That's a better example. So in order to change this into vertex form, we're going to complete the square. And what you do, if you remember from last year completing the square, you're going to subtract 12 from each side, so it would look like x squared minus 8x. And then when I teach complete the square, I make my students put plus blank is equal to, and then you're going to subtract 12 from this equation, and it's going to go over here on the other side of an equal sign, negative 12 plus blank. And in the blank, you put half of b squared. Half of b is negative 4. Negative 4 squared is 16. So you're going to add 16 to both sides. You're going to factor this into x minus 4 times x minus 4, which is x minus 4 squared. And then you're going to add these two numbers together. Negative 12 plus 16 is equal to 4. And then you're going to bring the 4 back over to the left side of the equal sign again. So the function in vertex form will be x minus 4 squared minus 4. And you can quickly look at this and say the vertex is at 4, comma, negative 4. The axis of symmetry, AOS, I call the axis of symmetry, is x is equal to 4. And you could easily graph this. You know this has been shifted to the right 4 and down 4, and then you can continue graphing that if you needed to. All right, here's our second example. A quadratic function, let's say f of x is equal to 2x squared plus 8x plus 7. And we're asked to write that in vertex form. So the first thing we're going to do is put the 7 over on the other side of the equal sign and call it negative 7. So he's moved over here. And then with what's left, you have to factor out the a value so you can complete the square correctly with a not equaling 1. So this is 2 times x squared plus 4x plus blank is equal to negative 7 plus blank. And now what goes in the blank? Half of b squared. 2 squared is 4, so you're going to add 4 in this blank, but you're not going to put 4 over here because what we've actually added to this side of the equation is we've added 2 times 4, which is 8. So just be careful. If a is not equal to 1, you have to factor it out, do complete the square with what's left inside, and then what you're adding to the other side of the equation is the a value multiplied by this new c value. So continuing this, you're going to factor this into x plus 2 to the second power. Negative 7 plus 8 is 1. And then you're going to subtract 1 again. So your function in vertex form is equal to 2 times x plus 2 to the second power minus 1. So what you have here is you have a vertex that's equal to negative 2, negative 1. And you knew this because this has been shifted to the left 2 and down 1, and it's been vertically stretched by a factor of 2. So vertex form is a nice form to change your regular quadratic function into so you can graph it easily if you need to. There's another form of a quadratic function that you should be familiar with. This is called intercept form. In intercept form, what you're being given is the intercept, the x-intercepts in terms of p and q. So f of x is equal to a times, that's the vertical stretch factor, x minus p times x minus q. And the x-intercepts are indicated by the p and q values. The x-intercepts are p and q. So for example, if you're given f of x is equal to 3 times x minus 5 times x plus 1, Your x-intercepts are 5, -1, and -1. The axis of symmetry goes halfway in between P and Q. And to get something halfway, you just add them up and divide by 2. So x is equal to 5 plus -1 divided by 2, which is equal to 2. You can change this intercept form back into standard form by first calling this f of x equals, and if you FOIL x minus 5 and x plus 1, you get x squared minus 4x minus 5. And then if you distribute the 3, you get 3x squared minus 12x minus 15. So that's just an irregular quadratic function form, which is the same as this function up here. And then if you wanted to turn it into vertex form, doing the complete the square, you'd say f of x is equal to 3 times x squared minus 4x plus blank equals 15 plus blank, and in the blank goes a 4, half of b squared. And over on this side in the blank goes 3 times 4, which is 12. So we have 3 times x minus 2 squared, and then 15 plus 12 is 27, so you'd have to subtract out the 27 from both sides. And here you'll have vertex form. And if you put this into y1 in your graphing calculator, and this into your graphing calculator under y2, and this under y3, you can look at the table of values, and you should do this. You maybe pause the video and do it right now. Put them into the 3 different y equals on your graphing calculator, and if you graph them, you'll see they're all the same parabolas. Or if you want to take a look at the table of values, you'll see all 3 table of values are the same. The last thing I want to talk about is to show you that if you have the vertex of a parabola and only one point on it, then you can write the equation of it. So let's say you're given the vertex and one point on a parabola. Write the equation. So for example, let's say the vertex is given to us as 3, 5. And let's say the point is given to us as...
May I have your attention, please? If you ordered a homecoming shirt...
And let's say the point on your parabola is given as 12, 32. And you're asked to write the equation of that parabola or that quadratic function. Well, the vertex is hk, so h equals 3, k equals 5, and the point on the parabola is x, y, so x equals 12 and y equals 32. So if you write this in vertex form, y is equal to a times x minus h squared plus k. There's your standard, there's your vertex form, and you just substitute y, x, h, and k, and you have to solve for a. So the y value is 32. You don't know what a is. X is equal to 12. H is equal to 3. You square that. And k is equal to 5. So 32 is equal to 12 minus 3 is 9. 9 squared is 81. A plus 5. Subtract 5 from each side and you get 27 is equal to 81a. And you divide both sides by 81 and you get 1/3 is equal to a. So that's all you need in order to write the equation of your quadratic function. And it will go like this. F of x is equal to a, which is 1/3, times x minus h, now you have to fill in the h value. The h value is 3. We were told that was the vertex, squared, plus 5. That's the k value. And there's your equation. And I think that's it for today.